Hi guys, and welcome to episode 4 of Mathematics of Deck Building. Today is the day. Today we are using the results that we got after more than 1 hour of testing hands last time. And we are using them to get some indication on the real probability of making construct in our deck. To do that, I will have to introduce to you some techniques that are coming from probability theory. But don't worry, it will be super easy. I will make it as clear as possible, and I hope that you will be learning something useful. And I will start with a recap of what happened last time. So if you remember, last time we ended with this information. The probability, and I will use some symbols here that I will explain while using. So the probability of making construct, knowing that opponent is not playing hand trap, was 69% or 0.69. The probability of construct when opponent has got hand trap, actually this is HT, is equal to 0.39. And the number of hands that we tested, we can call it N, is equal to 100. Now, what is this symbol here? This means that we are referring this small head. I write it here. It means that we are referring to the sample, so the 100 hands. Of course, it's not the real probability, because to know that we will have to draw all possible hands from the deck. And this symbol here that we will be using in the future as well, this means this bar here, knowing that. Okay? So basically, the probability of construct, knowing that opponent is not playing hand trap, in the sample of 100 hands of last video was 69%, when opponent has got one hand trap among Ash and Gamma, it was 39%, and the number of hands that we tried was 100. So this is the summary of last video. It's crazy, right? After 1.5 hours, we can summarize everything with this small piece of screen, but you know, that's how it works. Now, what is the point here? As I said, this number is not the real one, because if I draw another sample of 100 hands, I will get probably a different number, maybe 72, maybe 65. So what we want to know is actually the real probability of making construct, knowing that there is no hand trap. And I also want to know the real probability of making construct, knowing that opponent is playing hand trap. So this P in blue, you see there is no symbol, no head here. It means that this is the probability not of the sample, but is that of the deck. The one that we really want, the one that we could know if we draw all possible hands, but as you remember from the first video, it will be crazy. The number is simply too large. So what can we do? Well, the nice thing is that we can use these numbers to somehow estimate these numbers. And in this video, I want to explain you how to do that. Now, the thing is this: if some conditions hold, we can use an approximation. It's called the normal approximation, okay? And I will show you the formula, we will compute it together, and then there is also a calculator that you can use. So don't worry, but just follow me, because I think it's super important to understand what is going on. So this thing is called, by the way, binomial distribution. Binomial is when you try many times something where the outcome can be positive or negative, and then you compute the probability of success, right? So what is the idea? The idea is that if n, so this guy here, is large, and the probability is not close to either 0 or 1, then we can use an approximation. Okay? Now, what do you mean by large and not close to either 0 or 1? You may be asking. So this has been formalized in different ways. Usually what people do, they say that if, let's say this is equal to, if n times p is greater than or equal to 5, and n times 1 minus p is also greater than or equal to 5, then we are happy. So in our case, does it hold? Well, actually yes, because look at here, n is 100. This guy, for the no hand trap, let's write the no hand trap, we get that 100 times 0.69 is 69, and is definitely much greater than 5. And the second condition, we get 31 is much greater than 5. And also when we have hand trap is similar, right? We have 100 times 0.39, so we got 39 greater than 5 is true, and 100 times 61, okay? So you see that in both cases the condition is hold. So we can use the approximation. So what is the formula for the approximation? Don't be scared now, just stay with me, okay? I will make it as easy as possible, but I have to draw it because you need to see if we want to compute later the values. So the approximation is saying that, and let's use the blue color because now we are approximating this guy. The approximation is saying this. Let me write it here. It's saying that the real probability we are looking at is in a range, okay, and the range is p minus 196 times square root of p times 1 minus p over n. So this is the lower end of the range, and the upper range is actually the same, but we use plus instead of minus. Okay? So let me write the whole formula and then we comment. And this is with 95% confidence. So this, by the way, is called confidence interval, right? Based on the normal approximation. So what is the meaning of this? The meaning of this is simply that the real probability, so the probability of making construct, for example, if no entrap or also with entrap, we can compute both. But the real probability of the deck is in a range that can be computed knowing the probability from the sample and the sample size. And 95% confidence means what? It means that, you know, every time we run this experiment, we will get different results, right? If we run another 100 hands, I will not be so crazy to do another video like that. But if you do another video, you will probably find a different number, maybe 70, maybe 75, maybe 64, who knows? 63, it depends. Now, the thing is that if we compute this formula every time, for every time we run this kind of computation, the 100 hands, we get different ranges, right? Well, when we do that many times, the real probability will be inside 95% of such ranges. I repeat, if we repeat this procedure of drawing 100 hands, and for each one we compute one interval, the real probability that we are looking for will be inside 95% of such intervals. Okay? So now let's find what are the values here for the construct no-entrop and construct entrop. And to do that, we need to use our calculator. Now what I do is I multiply 69 times 069 times 031, divide by 100, square root, times 196, okay? And then we do 069 plus or minus that. So let's compute this value here. 196 times that, and then we report it here, okay? So let's go back. Okay. So what we have to do is, remember, is 069 times 031, right? Divided by 100. We compute the square root and we multiply by 196. Okay? So this is basically 009. We can approximate with 009. Okay? And then we can write that for, let's write it here. We say that this guy, for the construct no entrop, I just write here 0.09, okay? And what about this? Well, we do the same, but instead of 6931, we use 3961. That's right. So let's do it. So 039 times 061 divided by 100, square root, times 1.96. Now we have 0.1, basically, if we approximate, right? 0.1. So we can go back here, and you see the results are similar. So here we have 0.1. So what does it mean? It means that for construct no entrop, the range is actually 069 minus 0.09 to 069 plus 0.09. And for this guy here is 039 minus 0.1, 039 plus 0.1, right? So if we do this computation, is quite easy now. This means that the probability of having construct if no entrop is between 0.6 and 0.78. Let me write it here. 0.6, 0.78. And here we are 29.49. So this is the range of the real probabilities. What does it mean? It means that with 95% confidence, that is what I told you earlier, the real probability in the deck to make construct if opponent has no entrop is between 60 and 78%. The real probability of making construct if opponent has got entrop is between 29 and 49%. Now we can change this 95% confidence if we modify this number here, the 196, okay? And of course, if you want larger confidence, this number will be larger, so the range is larger. If you want lower confidence, the range is lower. But you also observe something interesting. If you increase the number n, this range is tighter, meaning to say the more hands we test, the more precise we are, because this range will be smaller. And now you understand why I was mentioning that if we just throw a few hands is not really cool. Maybe this condition is not even fulfilled, but even if so, the range will be very large. So what can we say if the probability is between 30 and 90%? Well, thank you, but it's not really useful. Here we know that at least is 60%, worst case, and worst case here is around 30. But again, it's important that we understand this idea of 95% confidence. Okay? Graphically, it means something like that. we run 100 hands and then we got a range, okay? So this is the first test. Test 1. Then we do another test, another 100 hands, and then we get another range, right? Then we keep doing that. We get another range, maybe another range like here, and then we may get a range here, another one here, and so on. The real probability P, suppose is somewhere like here, right? The real probability when we run this test many times, it will be inside 95% of the test, of the ranges. So see, here for example is inside, here is inside, here is inside, here is inside, here is outside, and here is inside. Okay? So that's what 95% confidence means. And these results are now telling something about the real probability, again, of making construct with the deck, just using the information we got from the sample. So it would be wrong to say that we can make construct 69% of the time if no entropy. It would be more correct to say that we can make construct with a confidence of 95% 60 to 78% of the time. And if opponent has got entropy, 29 to 49, so like 30 to 50% of the time, okay? Now, do you have to go through this? Not really, okay? I will show you there are some tools online that you can find to make this thing. And then this is one. I will put the link in the description. So how does it work? Here you write the sample size, how many hands we test, so it's 100. Number of positive, you remember in the no entropy case, we got 69 positive. Confidence level, we keep 95, but you can change. Default is using 95. The method, as I say, there is an approximation to be done. So what we use is called the normal approximation. There are others, but the formula I show you is that. So you can use that, and decimal places, just 2 is fine. So what do you get? We should get basically something like the range we got with the manual computation, and then you see actually it's true. 69 is the mean that we got, and the lower and upper range are 60 to 78. That is basically what we got here, right? And if we do the same for the construct with entropy, we just need to put 39. So we can do that if you want. So what we have to do is running again this. So you will see that we got exactly the same result. So at least you know when you are using tools like that, what is the logic behind. Okay, I think it's important to know, not really to understand how it was derived or the theory behind, but at least knowing what is going on. And then you see again, yes, 2949, that is exactly what we got here. So to summarize, in this lesson, what have we done? We started from the result we got from the previous video. So the values that were computed on the 100 test hands sample, and then from these numbers we were able to derive some information on the real probability of the deck. So now we know that the probability of making construct if no entropy is 60 to 78, and with entropy is 29 to 49. Of course, if we run more than 100 hands, we can get better results, like a tighter range. But now the question you may have is, okay, are you telling me that if I want to compare different builds of the deck, because eventually that's why we are doing that, to know if one version of the deck is better than another, are you telling me that I need to run these crazy 100 hands just to check if that new version is better than the previous hand? No, actually no. In the next video, I will show you a trick. It's a simplification, if you want, so you can find much faster the probability. Of course, there is some kind of error that you make, but you don't have to go through the 100 hands as we have done before. So don't worry, this was a way to get an information like that. Of course, you know, if you start to see that with a different build, you get a much lower range, you may, okay, say, maybe this version of the deck is not as good as the previous one, but you are not sure, because again, this is only giving you 95% confidence, and is a range. Of course, you cannot expect that by drawing 100 hands you can find precisely the number that you would find by running like thousands of hands. And I was thinking maybe I can make a code to do that. Yes, it's possible, so to try all different hands, but it will be very challenging to code the conditions that we tested manually. Remember, in the previous video, sometimes we had to go through AppCalone, so all these things where we have to think about, they will be very hard to be coded somehow. So that's what we can say at this stage. We move from saying something on the sample we had to say something on the deck, right? This is why this is important. These numbers are now referred, they are describing our deck. They are not describing anymore the hand we got. They are a description of the quality of the deck. So again, the next video I will show you how to use the hypergeometry calculator that we already introduced to find much faster an estimation of this probability, so that you will have an easy way to compare different builds of the deck. Wow, that was challenging. I really hope you stayed with me till the end. I hope it was not too hard to understand. I really suggest you, if something was not clear, watch the video again. If still is not clear, ask me. Write a comment. I'm more than happy to explain this to you, really. I'm not joking. Because when you have the basis, then you understand what you're doing, then you understand how to make a better deck, and you are supported by mathematics and statistics. It's not anymore, oh, I feel that this is better, or my friend told me that that way is better. No. This way you have a solid foundation for your decision making, and as a consequence, probably a better winning rate when you are going to play against opponents at the local or online, maybe currently because of the pandemic situation. So with that, I would like to conclude the video now, because I think it's already quite tough. I am very happy if you stay till this point. If you have not yet done so, subscribe to this channel, like the video if you like it, and also hit the notification bell, because I think it's very important to follow the whole set of videos of this course, because you see we are starting and we are building on what we have done previously. So it's very, very important. What to say? Well, thank you for watching, and see you next time.